Hi and welcome to our talk, Small Files and Big Bounties Exploiting Sensitive Files for this year's LevelUp conference from Bugcrowd. So what's on our agenda? First we'll talk about the history of sensitive files, give two examples, and then dive into the more technical stuff with a look at Git directories and DS store files. And yeah, explain a bit what sensitive content can be leaked with those files, and in the end motivate some other files and finish the presentation. So who are we? My name is Sebastian, aka Gehaxelt on Twitter. I'm a master's student at the TU in Berlin right now and doing a bit of freelancing stuff next to it. And I really like to play CDFs with my team Enoflag, and you can see me in Yekaterinburg in Russia at the Root CDF finals on the picture. So yay, play CDFs, it's fun.
Okay, so thank you very much for having us here. My name is Tim Philipp Schäfers. I'm also on Twitter and I'm a cybersecurity consultant, and I wrote two InfoSec books which are mainly in German, and in 2012 we founded the project internetwache.org, which is a project focused on web security.
And
So
you
let's
may
go.
have heard about us on the internet or on Twitter. So let's start. Tim is going to tell something about the history of sensitive files.
Yeah, I think we all know there were some sensitive files in the past. Here just two examples. For example, there are people on the internet who put sensitive stuff in the robots.txt. So it's a file to control the file indexing by search engines. You all know that Google or Yahoo are crawling those files, and there are people who put the direct path to some files into the robots.txt. And there was an article, for example, in the register that hackers find some interesting stuff in those files. So the problem basically is that there's no blocked access to these files, and even the idea of robots.txt is more to, for example, put a directory which should not be listed in search engines, but it's a nice information source for security researchers as well. And the second example we are looking at is the WSFTP Professional. It's an FTP client which was released in 1993, and it was very popular at these times. And even today, you can find some files which are named wsftp.ini, and it's kind of a configuration file which contains encoded passwords, hosts, and directories. It's pretty interesting that you still find those files, for example, on older websites, and you are able to get the encoded password out of it. So that was linked on insecure.org, for example, by a German security researcher in the late 90s. So pretty interesting, and now we will go on with some kind of current examples about that.
Yep, that's right. Some years ago, we looked into the Git directories, which you can find on web servers. So what is Git? You probably all heard about it. GitHub is an example that allows you to use Git repositories. So it's a version control system, which is developed by Linus Torvalds, and you can use it to manage source code. So yeah, for example, using git init, you create a repository. Using git add, you can stage files. For commit, using git commit, you commit them to the repository, and then you can distribute your commits using git push to a server, and other people can then pull those commits and the repository, and yes, you are free to collaborate on source code. So that's how the Linux kernel is developed, for example. So how does Git work? It uses a .git directory, which is located in the root of the source code directory or the project. And in the left-hand upper screenshot, you can see some directories. So there's branches, hooks, info, logs, objects, refs, and some, kind of important and interesting files, which are config, head, index, or description. So everything is based on objects in Git. So you see on the right screenshot that we have a commit object that contains a tree object, and the tree object references blob objects, which are more or less the files that you control using Git. So for example, the test.txt is a blob with version 1, and then when you commit another version of the file, you get another blob object with differences, and everything is managed using those object files. So you can find those object files in the .git/objects folder. You see that there are some subfolders, for example, the OA or OB, and the reason for that is to be more efficient in regards to the file system. So they take the hash of the object file and use the first byte as a subdirectory. So what happens if those directories, the Git directory, ends up on your web server? For example, when your deployment process is change directory /various/www/html, and then you just do a git pull to update your website source code. So there might be some people out there that do this, and yeah, so the Git folder will be exposed on the web server. And this is really bad. This can end bad because an attacker might just download the whole repository using wget in case the directory listing is enabled. So yeah, you see an example command wget --mirror --include directories /.git, and then yeah, the URL to the Git repository. And yeah, however, the directory listing is not always enabled on web servers, and it's best practice to disable it. So it gets harder to obtain the repository. However, we looked into how the things work and found out that in a Git repository, there's always the file's head, refs, heads, master if there's a master branch. So we can use those files to obtain one object hash. And with this object hash, we can download the object file. And from that object file, which is usually a commit, we can obtain the tree hashes, right? And from that tree object, we can obtain the hashes of the blob objects. So we can download all the files until we find no new hashes and objects file to download. So in the end, we end up with parts or the full repository on our hard disk. So for this, we developed a tool to automate this process. It's called Git Tools, and you can find it on GitHub. Let's do a demo of how this works and how we can obtain repositories from a web server. I have a web server running locally, and here you can see the web root. And yeah, with the Git directory, you see .git and the other files relating to our presentation. So let's make sure that directory listing is enabled. You see options plus indexes. That's great for the first example. So we can just use wget, as I said. We run that command and we download all the files. We end up with a folder, demo.local, and in that folder we see the .git directory. So we obtained it. We can use git status to see, okay, the files are deleted because the folder is empty. So what we do now, we use git checkout to restore the files. And as you can see, we downloaded the repository, we obtained the source code of our presentation, and we can use even git log to go through other commits that we did. So yeah, that's number one, the easy way. So let's do this again. After disabling directory listing, you see there's the files again, and now we use the git dumper that we wrote. It's a shell script that tries to download the files and recursively get the object hashes. So you see it tries to download, it finds some files, some other files it doesn't find, and in the end it downloaded everything. So let's change into the temp-pack2 directory, Again, we see the .git folder. We can do git status. We see the files. And now if we do the checkout again, we find all the files. Hooray! And the git log will also show what other commits are there. So as you can see, we obtained the full repository from a web server with and without directory listing enabled. So
Okay,
what
so
are
I
the
will,
consequences?
yeah. So thank you very much for your demo, Sebastian. I will just outline some of the consequences which directory or Git directories in general will have. So first of all, there's a problem that the source code is leaked. So it's possible to find, for example, vulnerabilities within the source code you find, or even committed credentials. And yeah, of course, you always have to stick to the rules of a bug bounty program. So if you found Git directory, you should only look further if this is allowed by the rules of a bug bounty program. The second problem is that very often in the Git config there are HTTP basic authentication credentials, and this can lead to an instant access to the company's repositories, for example on GitLab or GitHub. And of course, you may also be able to get an access to the CI, where the scripts are built and the auto deployment process of some server, will lead to a complete pawnage of the server. We did a scan on the Alexa top 1 million, which are the most visited websites on the web, and we found out that nearly 10,000 of those websites were vulnerable to this kind of attack, and we wrote a blog post about it. So if you want to go more into detail, see which top level domains are affected, you can go on our website. Yeah. Of course, this technique was also used by some security researchers. On the left side, you can see that somebody was able to find a .git repository and he got $1,000 for that. So yeah, that's pretty nice. And the SVN repository, which is a technique which is nearly the same as Git, was also enabled on a subdomain of Pornhub, and somebody got $10,000 for that because he was able to see some credentials. In this case, the password also was very weak. So yeah, that's a nice case which shows that .git repositories really should not be on the web servers, or at least there should be protection. Yeah, that's about the bounties.
Let's look into another example. This time it's about the file called .ds_store. It is a file format developed by Apple. It's proprietary, so we cannot easily read it. And you will find it on Mac OS. So what is this file used for? It holds meta information about files in a directory. So if you use Finder and access a directory on Mac OS, it will automatically create this file and save information, for example, the icons or display order or the file names of all files in the directory. And the funny thing is that this file is prepended with a dot, so the Finder won't show it per default, which is nice. But it's bad for you if you share a zip file or other files using a USB stick. So yeah, the other people might get information about what files are stored in the directory as well if you don't copy the whole directory. So that is pretty interesting, and we will come to some more information about it later. So I decided to look into this file format and write a parser for it. So I took some days to write that and understand the file format. But in the end, you will see something like on the right side, a screenshot. It has a tree-like structure and it has several blocks where it stores information about the files. For example, the file name. So these are the yellow marked bytes that are stored as not UTF-8 but UTF-16 encoded strings, so it uses 2 bytes per character, which makes parsing this a bit more interesting. And yeah, you can read the blog post if you want to get all the details about the file format. So what can go wrong if you use Mac for development and you then use SCP, rsync, FTP, or whatever file transfer protocol to transfer files from your local development environment to a server. So, for example, you see the figure on the right side where you have a code directory, you have a config PHP in there, you have two other folders in there, for example, with backup and a backup.sql. So if you all sync them to the server and don't take care to exclude the ds_store files, all the files might end up there, and by parsing the first one in the code directory, I will get the information that there's a config PHP, which is fine, or some other files, but I will also know that there's a backup directory. So by knowing that the ds_store files are created in each directory, I can parse that again, and then I will find out that there's a backup.sql without any brute forcing or other things, even if directory listing is disabled. So we've developed the tools for that, a parser that can read the file names from most of the ds_store files, and even a scanner for that to scan the Alexa top 1 million. So here's a short demo about that. Let's switch to the third pane in Tmax. This is our repository with a Python tool. So let's first look at the file. We have a sample file over here from a CTF that I played. We can even look at the hex dump. You see it's a lot of binary data and you can't read much. But by using the tool that I have developed, you will see a bit of debug output that I have enabled. So it reads through all the data, does a bit of black magic, and in the end you will have recovered 6 file names from that file. You see was a flag, which was interesting for the CTF, and also vulnerable.py. So we could have downloaded all the files from a web server where we found the ds_store thing and where access to the other files was not prohibited. So what are possible consequences of that? As I discussed, you can easily find other files on web servers without using brute force or having directory listing enabled. So it's kind of an information disclosure and makes finding other files easy. So what we learned from scanning the Alexa top 1 billion, where we also find about 10,000 vulnerable websites, that we can easily find backup files, for example, .bug, .gz, .db, so database files, email files, temporary files like .swap, the ones with a tilde at the end, or even key files where the private keys from SSL-enabled web servers were leaked. And you can see other things like config files, SQL files. So that can be really interesting. And people got bounties for that. So simply by finding the file on the web server, you can get more than $500 from Twitter, or even half of that, $250 from a private program that we participated in. And that's it. So easy to find, easy to exploit, and easy to get a bounty for.
Okay, so all in all, there are a lot of interesting files with sensitive content. We hope that you are now motivated and explore them by yourself. We put some examples of interesting files on the left side and would be very happy if some of you, for example, write a blog post about some files or some directory or resource he or she discovered. And we also want to outline that there are some interesting previous work on that. For example, Hanno Böck, which is a German security researcher, was at the 34C3, which is a hacker conference, and he had a talk hacking with wget, which was pretty interesting. We also wrote some blog posts on our website about finding interesting files. And there are some tools, for example, one of Hanno again, Snallygaster, which is a tool, and backup file artifact checker by Mason 160, which is also very interesting to find this kind of files.
And you will also find our tools for the store and for the Git stuff on our GitHub page. So github.com/internetwache.
Okay, so if you're interested in this topic and have some questions left or you have some feedback, we are very interested to hear about your questions or your ideas on that topic. So just get in contact via Twitter or email in this case.
Yep. And sorry for doing this in a pre-recorded session, but unfortunately I had to attend another conference on the same day, so I wouldn't be able to give the presentation. And yeah, sorry for that. I hope you enjoyed it anyway. And yeah, keep on hacking.